So in previous classes, we discussed about installation and then configuration and then patching. Like in the patching, how to apply the patches, uh, hot fixes and CUs and service packs. Also discussed about auto rollback and then troubleshooting things. Those are the things we discussed in yesterday class. In today class, we are going to discuss about warrior databases. In warrior databases, so we have a sub different topics in warrior databases. Those are server architecture and database architecture, database creations and database properties, server properties, log architecture, and warrior system databases. So these are the subtopics in warrior databases. And then we also have interview question and answers. Right, very important. So this topic mainly useful for understanding the internals of the SQL Server functionality and interview purpose. We don't to do any kind of work on these things like warrior databases, server architecture, just understanding, gaining the knowledge, understanding the internal components of SQL Server and database functionality, and mainly interview point of view. Like if you preparing for interview, we'll get questions from these topics. Maybe they will ask that server architecture, how SQL Server is functioning, how queries are flowing, and log architecture. Maybe they will ask about the system databases, right? So it's totally theoretical class. So we need some patience to understand these things because there is no practical work here. So only the theoretical things. Okay, but very important to understanding the internal components. So we already know that how to install a SQL server and how to connect the server. So we have a various options to connect the server, but the standard option is that using SSMS. So we need to connect, we need to open the SQL Server Management Studio, and then after that we need to enter the server name and we need to click connect. So this is the way we can connect the server. So this is the appearance of the SQL Server. Here we can see the database, security, different various options we can see here. And databases are in the database tab, and the login, security related information, security, right? And always on all these different folders we'll discuss later classes. Right, this is the appearance of the SQL Server. So in today class, we will see that how background, I mean how it will be functioning in the background. So those things we'll discuss now, right? So like how internal it is functioning, what are the different components, what are the different layers are in the background to functioning the SQL Server. These are all the things we will discuss in today class. Okay. Let me open the document. Okay, so this is the actual diagram for this diagram representing the SQL Server architecture. That's in background process of the SQL Server, right? So there are many components. So for simplifying, again we'll discuss all the components, but for simplifying this diagram, I drawn in different diagram. So we can follow this diagram. Later we'll discuss about this diagram, right? So that means SQL Server in the background, it is functioning in the four different layers. That means SQL Server is are under four different layers. The first one is the protocol layer, and the second one is the relational engine we can call it, and the third one is the story engine, and the fourth one is the SQLOS. Right? That means SQL Server is depend on or lies on the four different layers: protocol layer, relational layer, relational engine layer, and story engine, and SQLOS. So here first layer is protocol layer. Protocol layer we are using to establish the connection between application to server. Like here we have to understand the connection or process, like how the data is coming from SQL Server to data, application to database. Like for example, if you take an IRCTC application, that's mean IRCTC we are using to store our information of profile information, or booking or canceling the travel tickets. So the kind of purpose we are using. So that the kind of like when the source application or source A client which is used by the SQL Server simply can call it as an application, whether it is in online application, it is in normal application, or any client which is using to send or receive the data from the database. Simply we can call it as a application. So if we, I mean, as I take an example of IRCTC we are using for booking the train tickets for traveling, like cancellation or booking, or getting some information about the train's travel. And we also store our profile information in the IRCTC site, right? So that's, we can simply call it as an application. So most of the application in real-time environment, so whatever modifications you're doing at application side, those changes will comes to the second layer, second server, the server second server, we can call it as a application server. Application server will get the data from the application, and through application server it will send the data to the database server. Application server routing the to store the data in the database. So many applications are I mean having three different, I mean three layer application, three layer processing, we can call it. Application layer, application server layer, and then finally database layer. So in few applications are directly connected to the database. So they don't use the uh, they don't use the application server. They can directly connect between application and database server. So those kind of applications we can simply call it as a two-layer application, three-layer or maybe two-layer applications, right? So that's mean, so some applications routing the data through application to the database. Some applications or some processor directly storing the data to the databases, right? So here the protocol, what is the purpose of the protocol? Protocol, a protocol layer we are using to establish the connection and transferring the data. So using the protocol will establish the connection, and using the protocols we can transfer the data to the database. Like if you take the general example of protocol, like we are using for whenever in the internet, like if you are searching something in the Google, then those will go to the Google search engine servers. From search engine servers the data will be retrieved. So there it will use the HTTP protocol. HTTP protocol, through using HTTP protocol, the data will retrieve from the uh, Google search engines to database servers, right? So that's mean that there it will use the HTTP protocol. When it comes to the SQL server, for retrieving the data, processing the data, it will use the three different protocols. Those are TCP/IP, Name5, and shared memory. So these are the three protocols SQL server using for retrieving the data or establishing the connections. Right? Simply protocol we can define as a data retrieval, or maybe inserting or updating data processing between the server to application. And in SQL Server, we don't use the HTTP. HTTP is for internet and normal general internet operations. But in SQL Server, we are using the three different protocols. Those are shared memory, Name5, and then TCP/IP. So these protocols will install along with the SQL servers. No need to separately install the protocol server. When you install the one minute only. Okay. So in SQL Server, it will use the three different type of protocols: TCP/IP, shared memory, and Name5. So these protocols will automatically install and installing SQL Server. No need to separately install. So, like here, as I said, that we have three different protocols, but we are using for various options. The first, shared memory. When we go for shared memory, in the sense when application server and then database server both are running in the same server, same operating system, that time we can use the shared memory. If you remember, like when you're doing your academic projects, that time we are installing the application, and then we can also install the database server in the same operating system, the same laptop or same machine, same operating system. Those kind of situations and scenarios, we can use the shared memory. When application and database both are running in the same machine, same operating system, we can go with the shared memory. So the second protocol is named files. Named files means when SQL Server and application both are running in the same network, the time we can use the shared named files. For example, in real-time users, we have two different type of applications. One is internet application. The second one is the intranet application. Internet application means it can be accessible from anywhere without connecting any specific network. Intranet sites or maybe internet application means within the network only we can access the applications or maybe sites. For example, www.sbi.com. So this is the one of the application. www.sbi.com means it can open in anywhere without require any kind of permissions. We can directly open and we can see all the information www.sbi.com. Like SBI employees, they have their own application to update the account holders information or maybe money transactions information. So they are using the different tools. Those tools cannot be opened outside SBA network. They want to open, they want to update SBA accounts, SBA account holders information. The first thing they have to connect to the SBA network, then only they can open their sites and they can update the information. So those kind of operations or applications or applications, we can call it as a intranet application. Okay? So when you want to use it SQL Server for intranet operation, then time we can use the named file. When application and the database both are running in the same network, then we can use the named file. Right? And the third layer is the TCP/IP. TCP/IP is a widely open network. Again, it will work for intranet and internet sites. And in the real time, we are we mainly using the TCP/IP protocol we are using. That is the reason after installing the SQL Server, if you remember in the post configuration steps or maybe post server installations or maybe configuration steps, what we did, we verified whether TCP/IP protocol is enabled or not. If not enabled, we need to enable. If you not enable or maybe somebody disable the TCP/IP protocol in real time, after that means the application not connect to the SQL Server. That is the reason we need to ensure that the TCP/IP protocol must be enabled. In the most of the cases, the TCP/IP will enable after installing the SQL Server. Maybe some reasons if not enabled, then we need to manually enable TCP/IP protocol. We already know that how to enable, how to disable, and where we can find the protocol information. So we can find protocol information in the configuration manager. In the configuration manager, we can view uh, all the servers information, all the servers protocols information. Right. So in the SQL Server architecture, the first layer is that protocol layer. First layer is protocol layer. Protocol layer we are using to establish the connection for connectivity and the data processing. We are using the protocol layer. The second layer is that relational engine. If you're clear about first layer, protocol layer, the second layer is relational engine. And there is one more protocol before 2012. The protocol name is VIA, Virtual Interface Adapter. So this is mainly using for huge amount of like computers, huge amount of data processing, the kind of related applications or database. We prefer to use the VIA, Virtual Interface Adapter. But from 2012 onwards, the protocol is duplicated. That's when they are not using. So no need to worry about the VIA protocol. Okay. Anyway, before 2012, those versions are outdated. No need to worry about it. But from 2012 onwards, we don't have a VIA protocol. Okay, clear? So if you're clear about the first layer, that is protocol layer, the second layer is relational engine layer. Relational engine Generally you can call it as a relational engine. This is the second layer of the SQL Server architecture. So in the relational engine, there are mainly three different components. Parser, the second one is the parser, optimizer, and query executor. So these are the three important components are in the second layer, that is relational engine. Parser means syntactically verify whether the query is correct or not. Whatever queries are executing, either from the application or from directly in the SQL Server using SSMS, parser will verify whether the queries are syntactically correct or not. The kind of verification done by the query parser. The second one is the query optimizer. Optimizer will generate the plan how query needs to be executed. It is always trying to give a best plan for executing the query. For example, you're executing one big, the long transaction, like the transaction is retrieving the data from the multiple tables or multiple databases, right? So the query once start executing, then parser verifies syntactically query is correct or not. Once query is correct, that information will pass to the query optimizer. Optimizer will analyze that. It will analyze how much memory is retrieved and from which table, which index, which column the data needs to be retrieved. All the kind of information it will gather, and it will try to give a best plan for executing the query. Right? So optimizer depend on the statistics. Like every table, so we have an option to create the statistics. So the statistics contain so in the performance tuning classes, we'll understand more about the statistics. But here we just understand that statistics contain the metadata of the particular object. The statistics contain the how much size the table has, how many rows, how many columns, that's the kind of information the statistics contain. Again, optimizer will depend on the statistics information. Based on the statistics information and based on the query, it will generate the B-tree plan, B-tree structure for executing the query. You just understand that here. So again, in the performance tuning classes, we'll see that how optimizer will generate the plan in the background. These are all the things we'll listen. Here, just understand in the architecture classes, we have to understand what we need to understand about optimizer is generate the plan for executing. It always tries to give a best plan for executing the query. Right? Only the point we need to keep in mind for now. In the architecture classes, in the performance training classes, we'll understand more about the optimizer. Right. So that's about the second. That's the role for optimizer. Once optimizer generates the plan, then that information will pass to the query executor. So based on the optimizer plan, whatever plan given by the optimizer, the executor will try to execute the query based on the optimizer plan. While executing the query, that means these are three operations mainly performing on second layer of the SQL Server. That is called as the relational engine. Parser, optimizer, and query executor. Right? If any operation is failing, for example, if parser identifying the wrong syntax. If it identifying the wrong syntax, then that information will again send back to the application through protocols. So again, if in some reasons, maybe optimizer is failed to generate a plan, again because of a locking mechanism, because of lack of resources, again that information will send back to the application through protocol. Like here protocols, we are using a way for transferring the data between application to database. Right? The same way for execute. Any operation is failing, the same information sent back to the application via protocols. Right? So once partial is gave it gave the proper verified synthetically correct, and then optimizer generated the plan, and then it will send to the executor. While executing the query, it will connect to the tar layer. It will connect the tar layer using the OLDB provider, another different connectivity. Okay. So the relational engine and the story engine. Story engine is the third layer of the SQL Server architecture. So from second layer to third layer, it will connect through OLEDP protocol. This is the internal protocol. Okay. So then coming to the third layer of the SQL Server operation, that is the store engine. Store engine contain the many components. So the many operations are happening in the store engine. Back to the third layer, this is the store engine. In the store engine, we have almost 6 different individual components are in the store engine. The first one is the transaction services. Transaction services is controlling the transaction process. So first here we have to understand what is transaction, how it will control the, how it will, what are the operations controlled by the, are verified by the transaction services. Transaction means we can define as a uh, group of options, or maybe group of queries, or maybe group of statements. Simply you can call it as a transaction. Like for example, if you take an online transaction, online money transfer transaction, if you want to do that, like what are the internal operations? That's mean first operation is that it will get the money from the source account and create to the other account. And before that, in the middle of the process, we have a OTP process. That's means getting the money and creating the money and verification, authorization process. That's when we need to enter the OTP to confirming the transaction or something. That's when it has the simply can define the single money transfer transaction as three different operations or maybe different processes. Right? Getting the money, getting the money, and validating the authentication, authorization, and then creating the money. So if any process is failing, like fail to get the money or fail to authenticate it, authorizing the process, like if you enter the wrong OTP or something, if it is failed again, the entire transaction will be failed. Right? So now we are clear about transaction. Transaction we can simply define as a group of statements or group of processes. We can call it as simply transaction. Like as per DBMS concept, database management systems, DBMS or DBMS system, every transaction must follow the ACID properties. Okay, ACID properties means atomicity, consistency, isolation, and durability. Every transaction must follow these four properties. Every transaction. Atomicity means either all the transactions, either all the operations or statements should be completed or none of them. Okay. If you take a transaction, either all the transactions should be completed, or if any operation is failed, the entire transaction will fail. Either all the transactions should be a success or none of them. Okay. So that's taking care of the atomicity. The second one is that consistency. Every transaction should be in the consistent state. Like for example, if you are using any relational tables like parent table and child table, like if you update anything in the parent table, the same information updated in the child table. If you do anything in child table, the same kind of information also updated in the parent table. So that means that the transaction should be in consistent state. Like whatever amount you debited from the source, the same amount should be credited into the sender, I mean receiver. Okay. So that's about the consistency. And the second one is that isolation. Every transaction should be isolated from the other transaction. Every transaction should be unique. It should not depend on the other ones. So that tells about the isolation. The fourth one is the durability. After completing the transaction information stored somewhere permanently. That is controlled by the durability. That means whenever you're doing any kind of transaction in SQL Server or any RDBMS, that's when every transaction must follow the ACID properties. If any properties is failing, then the transaction will be again rolled back. Here in SQL Server, the third layer storage engine, we have a transaction services. Transaction services mainly verifying whether transactions are following the ACID properties or executing properly or not. The kind of information is taken care by the transaction services. And we have a write head log algorithm. Again, in the database architecture I will explain. Again, so write-ahead algorithm is also controlled by the transaction services. Okay, so that's about the transaction services. And the second one is that file manager. So the database contain many, we can create multiple data files for database. All the data files, information, locations information, the kind of all this information will be in the file manager. And the third important property in storage engine is that buffer manager. Buffer means the sense, buffer is nothing but a RAM. Like all the operations are performed in the buffer manager. Uh, the data in SQL Server, the data will be stored in the data files in the drives. But when it comes to the operations or modification, those are not directly happening in the disk subsystems, like in the storage level. So all the changes and modifications are happening on the buffer manager. Again, our database architecture will understand the buffer manager, right? So here just understand buffer manager is a response. Buffer is nothing but a RAM, and the buffer manager we are using to do all kind of modifications. Right? It is playing very important role for transaction processing. And then coming to the next one is that lock manager. Lock manager is assigning the locks based on the operations. Like again, so we have 6 different type of locks available in SQL Server. Share lock, like when you're doing the select operation, that time it will assign the one type of lock. When doing the insert and delete update, when it will assign the different lock. Like we have 6 different locks are available in SQL Server. Share lock, exclusive lock, update lock, intent lock, bulk update lock, schema lock. We have 6 different type of locks we have. Again, so this locks mechanism, how locks are created, how impacted, how the lock will be created. So all these things are comes under the performance tuning class that I will understand more about. Here just understand lock manager will assign the locks to maintain the concurrent transaction in SQL Server, and we have 6 different type of locks. Based on the operation, it will automatically assign a lock on the particular transaction. So only that point, those points we have to keep in mind of the later in the performance tuning classes, we'll understand, we'll gain more knowledge about locking mechanism. Right? And moving to the next component, access methods. So access methods we can define as a like mediators. Like so the access methods contain the what kind of data needs to be retrieved, what kind of needs to be modified, the kind of information have. I mean the kind of information these access methods have. Right. So like I mean what table, what I mean whether we need to do the select or insert update, the kind of information will be in the access method. So access methods will pass that information to the buffer manager. Buffer in the buffer manager, the data will be modified. Simply you can define access method is work like a mediator, and the access method knows so what kind of what kind of operation needs to be performed. Whether select or insert update, the kind of information will be in the access method. And the fourth one is that the next one is that utilities like bulk load, DBCC, backup restore. These are the standard operations, backup restore, DBCC command, and the bulk load. So when you're doing that time, these internal utilities using to perform those operations. Right? This is about the story engine. This means most of the operations are happening in the story engine. Transaction services, file manager, log manager, buffer manager, and utilities. So these are all in the third layer of architecture, that is story engine. So clear about story engine, then the next and the final layer is SQL OS. So here OS means simply can define OS is giving the instructions how to do that. It will assign the required memory, it will assign the CPU threads to completing the operations, right? So OS we have a Windows OS, that's mean Windows OS is giving all instructions to do the operations on the Windows operating system. Right? That's mean It's like mainly OS contains the memory process, operation process like CPU central processing unit, like giving the instruction to complete the operation, error handling, and resource monitoring, and thread management. These are the operations are the OS. Again, it's a different concept. No need to worry about it. Right. So OS is controlling these kind of operations. It contain it handling more, but these are the default. Uh, these are the few operations controlled by the OS. Right. So before SQL Server 2005, so SQL related operations also depend on the Windows OS. That's mean it's depend on the Windows instruction to completing the operations in database. But from SQL Server 2005 and above versions, it has its own operating system. That's mean it doesn't depend on the Windows operating system to performing the database related operations, because all these operations are depend on the SQL OS like memory management and thread processing, synchronization, scheduling, error handling, resource monitor, everything. All these kind of operations are depend on the SQL OS. Before 2005, it will. I mean, these are all operations are dependent on the Windows OS. Okay, but SQL OS lies on the Windows operating system, but all SQL related operations controlled by the SQL OS. Right? So here the main important components in SQL OS is memory assignment, IO manager, IO in the sense read and write operations controlling, and worker threads, exception handling, deadlock detector, thread scheduling, synchronizing services, lock manager, like lock manager in the sense resource level locking means when all the operations locked by the memory or memory CPU, the kind of locking, the kind of information contain the lock manager. Like there is in the second layer we have a lock manager in the SQL OS. In SQL OS mainly related to resource wise locking mechanism, and in the second layer in the storage and locking mechanism, it's totally depend on the operations like insert and delete, like object level locking mechanism. Right? So this is about the SQL OS. So SQL mean, for example, if you're executing the one single transaction, so how much memory is required? The memory is assigned by the SQL OS, and it will also assign the worker threads. Worker threads means it will send from the CPU to completing that operations. Right? It's totally different concept. No need to worry about. Here SQL OS is controlling memory manager, IO manager, and scheduler, and worker threads, and then a resource monitor. So resources in the sensory, CPU, memory, and network. All right. So these are all we simply call it as a resources. Resource monitor and deadlock monitor, deadlock detection. So again, we have a separate class for deadlock. So deadlock monitor, deadlock analyzing, scheduler operations, everything will controlled by the SQL OS. And here, if you see that there is a buffer pool. Buffer pool contain all the cache information, right? So buffer pool simply can call it as a all the cache, like whatever operations recently performed, all those information in the buffer pool, right? So buffer pool simply can define as a cache storage, cache information, storage location. We can call it as a buffer pool, right? So again, so buffer manager and buffer pool we'll understand more in the database architecture. So buffer manager we are using to perform the all the kind of operation. Buffer pool contain all the cache information, right? So that's about the SQL Server architecture. Very important interview questions. So most of the interviews we can get the questions. Tell me about the. So maybe sometime they'll ask about entire server architecture. Sometimes they'll ask about only the specific protocol, specific layer. Can you explain about the storage engine? Can you explain about the SQL? Can you explain about maybe protocol layer or maybe relational? So in very rare cases, they might ask about entire server architecture. Okay. If you're summarizing the server architecture mainly contains the four different layers. Those are protocol layer, relational engine, storage engine, and SQLs. Protocol layer using to data transfer, like this, it will do this like a mediator to transfer, sending or receiving the data from uh, clients or web application to databases. And we have three different type of protocols in for SQL Server. Then coming to the second layer, store engine. Store engine contains the relational engine. Relational engine contains the parcel, optimizer, and query executor. Parcel will verify syntactically whether query is correct or not, and optimizer will generate the plan how query needs to be executed. And query executor will execute the query based on the optimized plan. And while executing the query, it will connect to the storage engine, that is third layer. The storage engine, there are many component transaction services and file manager, buffer manager, lock manager, and access methods. Okay. So, so the while executing query, it will connect to the storage engine and then through ILTV provider, and then whatever information needs to be updated or modified, that will contains in the access method. Access methods will give the information to buffer manager. In the buffer manager, the modification will be happening. Right? So, like, and then coming to the fourth layer, SQL voice. SQL voice is assigning all the required resources to execute in the queries, like memories and main CPU worker threads, and then exception handling, and then resource monitor, and executing some default threads like deadlock monitoring and scheduler. Everything is controlled by the SQL voice. So that is the way we can explain in interview content. Right? So, have any questions? Okay, so if we're clear about it, now move to the next one. That is query processor relation. Sorry, the query workflow architecture. Okay, so in this topic, we'll see that how queries are coming, how queries are executing, like select statement and set statement, update statement, the kind of things we'll discuss. One minute only. Okay. Okay, so in this topic, so what we are going to discuss means how the queries, like how select statement, how insert statement, how update statement or delete operations, how executing from application between application and database server, right? We already know about what call application, right? So simply any website, www.tcs, www.google.com, these are all we can simplify it as an application, or any sites like Redbus or IRCTC, everything, online banking sites, everything we can call it as a application. Generally, application developed by the programming languages. We can use the various programming languages like C++, Java, .NET, maybe different programming languages we can use to develop the application or sites, right? So, and when using the application, applications are providing human readable language of interface. Like we can read and we can it can understand the human readable language, right? So when it comes to the database doesn't understand the human readable language. Like it doesn't understand all kind of human readable language. It only understands the PSK language. Sorry, SQL language, structure query language. Structure query language means insert operation, delete operation, truncate, insert, update, delete. We discussed these things in first class, like insert, create, alter, drop, insert, update, delete, truncate, select. These are all we can call the structured query language. RDBMS softwares only understand the structured query languages, but applications are developed by programming language, but the applications are understand and human. I mean, applications understand the human readable languages, right? So how it will be converting, how the data will be coming. So these are all the things we'll discuss now. For example, if you take IRCTC, like we can update the, we can search the all the trans information. So like search in the sense it will take it as a self statement. So when you book the ticket, if you click the submit, then it will take it as a insert statement. And for example, if you do the insert statement, if you click the submit button, that information will be storing in the database. When you click the submit button, assume that it will take it as a select insert statement, and so that will be done in the, I mean, that operation will complete in the application side. So here we can assume that we have an application that are written by the VB code, very old programming language. Okay, so once click the submit button, then that information will convert it to the SQL understanding languages. For converting, we can use the various libraries. For example, if it is .NET related languages, .NET framework support more than 60 programming languages. If you are using .NET, if you're using .NET related framework related languages, it will use the ADB OLEDB. That's mean it will convert to application language or maybe user understandable language to SQL Server understandable language using OLEDB libraries. So if it is Java, we have JDBC, ODBC converters. There are many. So it will use the database library to converting to SQL understandable language. Then after that, the data will be transferred through TCP/IP. Like we discussed about protocols, right? So the protocols we also need to install at application. So when database are installed, automatically protocols are installed along with the SQL Server. Again, so we have to separately install the protocols at the client side. Which means protocols should be there at application server as well as database server. Okay. So again, there are protocols, and the data will be transferred through protocols. Here, how the internet data will transfer to the, like maybe if we take the general example from Google searching into our laptop, like something you're downloading or maybe something you're watching. So that means the data will be transferred through protocol, HTTP protocol, in the form of sockets, or maybe we can call it as a pockets. The data comes through pockets, like the pockets contain the specific amount of data. Through the pockets or socket, the data will come. Again, in SQL Server also, it will use the sockets to transfer the data. So in SQL Server, I think by default 4 KB data will be in the single socket or pocket. We can, if you want, you can increase, and it's totally depend on the network bandwidth. If it is a network bandwidth is very good, huge amount of data will fastly come to the database, right? So that's mean the data, the some amount of data through protocols in the form of sockets or pocket, the data will transfer. Okay, so it will comes to the then client OS network libraries, and then and again then after that the data will transfer to the server network protocol, and then it will verify the whether ports are accepting or not, and then after that it will also verify whether the connection is successful or not. Once connection is successful, then it will go to the then there is a one more service we can call it as open data services. Okay, simply can call it as ODS. So what ODS will do that ODS will collect all the data, whatever data we are sending from the application, it will collect all the data. Like as I said that it's a previous hub data will come, so it will collect the home data, maybe collect all the data, and it will send to the relational engine. That's mean, for example, if you're inserting 10 GB data, 10 GB data will transfer through TCP protocol and then it will establish the connection between application and server through protocols, and then after that, so that means 10 GB data will not send in a single shot. It will come through form of sockets and maybe packet. So ODS service, Open Data Service will collect all the data. All the data will send to the relational engine. Okay. So once data comes to the relational engine, again there is another authentication process. Like on whatever database you're executing the data, it will verify whether you have permissions on the database. We have permission to write the operations like insert or delete or select. The kind of validation it will happen. If it has permissions, then parts it will verify syntactically query is correct or not, and then optimizer will generate the plan. And then for executor will execute the query. While executing the query, it will go to the story engine, and in the story engine we have a file manager. That's mean it managing the files. The data will be stored into the database files. Once complete that operation, again it will send a notification that the transaction is completed successfully. So this is the way the internally the operations are flowing. Right, it will go to the data library. In the data library, it will verify, I mean, it will convert it to a SQL understanding language, and the data will be transferred in the form of sockets or token, and establish the connection between application to server, and then ODS collect all the data and send to the relational engine. In the relational engine, whatever database you're executing, again it will verify whether you have permissions on the particular database, and whether you have authorized to execute the kind of operation or not. The validation will be done, and if validation is successful, then it will follow the remaining steps: parsing, optimizing, executing, and like storing the data permanently in the database files in the disk level. And then whatever resources required to complete this operation, then SQL will provide all the resources. Resource means memory, CPU, again this kind of read and write operations, IO, and CPU, memory, network. These we can call it as a resources, right? So that's about the query or I mean workflow or something we can call it. Sometimes maybe instead of server architecture question, you'll get the query overflow. How query? Can you explain about the query overflow? Overflow in the SQL Server. Might get this question sometime. So here in the bottom we can also see the steps. So that's all for today's session, Andy. So if you have any question about today's class, you can ask now. If you don't anything, we'll wrap up now. So and then we'll continue with database architecture tomorrow, because two people did not join today. So I don't want to take much time. Again, it's like so totally theoretical. I mean, the primary thing is that it's a totally theoretical. Like again, if you go to the another theoretical, it will be you will be get confused. So we'll stop for now with this topic. So that means server architecture, and tomorrow we'll discuss about database and log architecture, database architecture, and then now system databases. All these kind of things we'll discuss on tomorrow class. Okay, Nandi. So that's for today, Andy. So if you have any questions, you can feel free to ask me. If you don't have, we'll wrap up now and then catch up on tomorrow.
ప్రీవియస్ క్లాసెస్లో కొంచెం డౌట్స్ ఉన్నాయి.
చెప్పండి పర్లేదు.
ఆ సర్వీస్ ఉంది కదండి, ఇన్స్టలేషన్
కరెక్ట్.
రిజిస్ట్రేషన్ టైంలో ఒక పాస్ అడుగుతుంది ఏంటండి?
సో ఆర్ సర్వీసెస్ ఇన్స్టాల్ చేయాలంటే లైక్ ఫస్ట్ వీ హ్యావ్ టు ఇన్స్టాల్ ది JVM. It is a free requisites for JVM. If you not install JVM, then our services will not execute. It will install. And I think during that our services installation processor, it will ask it will take the default location. If you want, you can also specify the your own location, like whatever location you want to prepare. And more importantly, no need to worry about our services. Very rare cases we are using. So our services mainly related to Python language. We must know the Python language to handle the R services. And R services mainly using for used by the data scientists, like whoever analyzing the data, the
Data
kind of
analyst, right?
operation. Yeah, so the kind of operations we can do that. Even in our environment, I never install the R services. Only we install on the test machines, but in the production servers, we did not install R services so far.
నెక్స్ట్ వన్ మోర్ థింగ్, పాలిష్ సర్వీసెస్ ఇన్స్టలేషన్ టైంలో ఒక ఎర్రర్ వస్తుంది. ఆర్కిల్ జేఆర్డి 7 అప్డేట్ లైక్ దిస్.
సో అది వచ్చేసరికి
వాయిస్ కట్ అవుతుంది. హలో నరేష్ గారు, వినిపిస్తుందండి వాయిస్ నాది?